Here we see the cell cycle in all its glory. The cell cycle starts with the G1 phase and is followed closely by the S stage, G2 stage, and mitosis.
In this video, our main focus will be on the S phase, or synthesis, where DNA replication takes place. Here we see a strand of DNA, composed entirely of nucleotides. These nucleotides are made from a sugar, a base, and a phosphate. The bases are the part of the strand which will be the focus of the replication, and their names are adenine, thymine, cytosine, and guanine. We can also see that the DNA strand has an anti-parallel structure. This is shown by the fact that the strands run from 3' to 5' in opposite directions.
Zooming in on a smaller DNA portion, we see the first step in DNA replication taking place. The helicase enzyme cuts straight down the middle of the DNA strand, splitting it into two parts, which the primase enzyme can easily read and prime for replication.
The next step involves the primase enzymes, which will move from 3' to 5' along the strands of split DNA. These primase enzymes are in charge of priming the split DNA. This primer prepares the DNA for the next step in replication by laying down a basis that will let our next enzyme, DNA polymerase, know what nucleotides need to be placed in each spot.
The third step of this process involves a polymerase enzyme moving from 3' to 5', closely following the primase enzyme. This polymerase enzyme travels along each side of the split DNA and places down nucleotides to match the ones already present, which creates two brand new, identical strands of DNA.
The final step of the process is that a couple of ligase enzymes will come through the new DNA strands and fix offset DNA pieces that aren't precisely lined up. After this step has been completed, the two new identical strands of DNA have finally been created.